All right, this video is a continuation of part 2 from last section, which is 6.1 for Trig and 5.1 for pre-cal. We are still verifying Trig identities. So in this example, we don't see any squares, so it's a good idea to skip Pythagorean for now. So I have the option of changing everything to sine and cosine, or trying to add, subtract, multiply, or divide. At this moment, I can't combine anything unless I have common denominator here, which with secants and cosecants might get a little wild. So I'm going to suggest that we change everything to sine and cosine. Okay? So this first part is going to read sine of x divided by cosecant turns into 1 over sine of x plus cosine of x stays the same, and then secant turns into, nice, 1 over cosine of x. And then I have sine of x times, and cosecant turns into 1 over sine of x. Are we good up to there? Now, I don't know about you guys on this left side. Anytime I see multiple fractions together in one, I like to write them horizontally, okay? So it might be easier for you guys to see this first part as sine of x divided by 1 over sine of x. Okay, that's this first big fraction. And then I'm going to add it, and I'm going to do the same thing with this one with the cosines. I'm going to say cosine of x divided by 1 over cosine of x equals, and on this right side I end up with sine of x over sine of x. What is that going to end up cleaning up to? 1. So that should already start giving you a head start that my left side should end up giving me 1. Okay? Now, on this left side, I am dividing fractions. What do I do when I divide fractions? Keep, change, flip, or multiply by the reciprocal. Very nice. So I have sine over 1 times, and I flip this one to sine over 1 plus cosine over 1 times cosine over 1. And we said that this right side is going to equal 1. Now, what does sine times sine give me? Sine squared plus, what does cosine times cosine give me? Cosine squared. And this right side still equals 1. What does sine squared plus cosine squared equal? 1. Once I have the left and the right saying the exact same thing, I am done. Okay? So for this next question, as I peek through it, I definitely see some squares. I see the 1 plus tangent squared, and I see the secant squared. Now, 1 plus tangent squared will become secant squared according to the rules we talked about last class. And it condenses these two terms into one. Cosecant squared can become 1 plus tangent squared, but then I'd be making my problem bigger when I want to try and start condensing things and making it simpler. Okay, so for step 1, I'm going to say cotangent of x times, this turns into secant squared of x over tangent of x. And then again, I don't want to turn cosecant squared into 1 plus cotangent squared because it's going to make my life a little more complicated. You can either leave it as cosecant squared for now, or when we take the step of changing everything to sine over cosine, you can change that as well. Okay? So I'm going to change this to 1 over sine squared already. So for my next step, so that I start seeing things a little cleaner, I know I'm going to change these to sines and cosines, which would make fractions within a fraction. So I'm going to take a minute and write cotangent of x times secant squared of x divided by tangent of x. Okay, and my right side's going to stay the same, so I'm just going to draw an arrow down so I don't have to waste too much time. So now, if I'm changing things to sine and cosine, what does cotangent become? Nice. This one becomes cosine over sine. What does secant squared become? 1 over cosine squared. And then I need to keep change flip. So I need to say times 1 over tangent. Or for now, actually let's do this instead. Let me show you why. Well, can't find my whiteout, so this is going to become a division symbol. I'm going to say divided by tangent becomes sine of x over cosine of x. Okay? So now, again, there's many steps you can start taking. You could either do your keep change flip and say times and flip this one. Okay? Or I could start cleaning this. Remember, when you are in the step of multiplication for a fraction, only multiplication, you're allowed to cancel out any one numerator with one denominator. So the fact that I have 1 cosine up here and 2 down here, I can already start cleaning that if you want to. Okay? So again, I have 1 cosine up here, and I have 2 down here, so I'm only going to take 1 away. So I could say, in my numerators here, I have 1 left. And then in my denominators, I have a sine left. And I have 1 single cosine left. Okay, that's these two together. And now, if I'm dividing fractions, I'm going to change to multiplication and flip this to say cosine of x over sine of x. All right. Now, once again, I find myself in a step of multiplication with fractions. So again, I can cancel out one thing from a numerator with one thing from a denominator. What do you think I can cancel here? Another cosine, right? So what am I left with in my numerators? Nice. 1 over in my denominator, I have 2 sines, so I can write sine squared, which is what I had all along on my right side. Okay. The left and the right say the same thing, so I am done. All right, this next question, I want to make sure that you don't get deceived in thinking that these can turn into the Pythagorean rules, okay? Sine plus cosine cannot equal 1 because it does not have the squares. Same for 1 plus tangent. So those have to stay as they are right now. Now, I want to remind you of something you learned a long time ago in some other math class of cross multiplying, okay? Back in the day, you would solve for x, you would cross multiply, and you could here find out when you divided 2 that x equaled 5. You were allowed to do this because there was a single fraction on each side of the equal sign, okay? That same concept is going to apply here. Because I have a single fraction on each side, I am allowed to cross multiply. So let's check out what that looks like, okay? If I say this tangent times down here, so I'm going to cross multiply these two, okay? I can say tangent of x. Now, please be careful. Make sure you write parentheses if there's 2 terms. Bless you guys. Sine of x plus cosine. So the biggest mistake you can make here is forgetting these parentheses. Tangent does have to get multiplied to both of those, okay? Now, let me grab a different color. I'm going to do the same thing with the other side. I'm going to say the sine times the 1 plus tangent. And those two are going to get multiplied. So again, I'm going to write sine of x, and then in parentheses times 1 plus tangent of x. Okay? Now, before I start changing everything to sine and cosine, I'm going to distribute. Okay? So this tangent is going to get multiplied to both, and same for this sine. So both terms, okay? So it's going to look a little lengthy, but bear with me. This is going to clean up really nice. I have sine of x, tangent of x, plus cosine times tangent. We're all good with that left side? Just distributing. And then sine times 1 is just sine, plus sine times tangent is sine of x times tangent of x. Okay? So whenever you see a step like this that looks really lengthy, I want you to take a pause and like scan across it. We have 4 terms here. We have this sine times tangent, this cosine times tangent, this sine, and we have another sine times tangent with the same exact sign. So if I subtract this sine times tangent over here, they will cancel out, okay? Whenever you have the same exact term with the same exact sign on both sides, they will cancel out. So all I'm left with is cosine of x times tangent equals sine of x. What step do you want to take next? So I have students suggesting different methods. So I'm going to show the different methods that they're suggesting. Method number 1 that was suggested was to divide the cosine over, and then I would have tangent of x equals sine of x over cosine of x. And even here I have 2 methods that were mentioned, because here you can change tangent to sine of x over cosine of x, right? And now I have the same thing on both sides. Here's one option. Another option is to change the sine over cosine to a tangent. So now I have tangent of x equals tangent of x. Okay. Here's another option. Hope all my arrows don't confuse you here. And then from back on this step, maybe you thought of the 3 steps that we had written last class and you wanted to change that tangent. So you would have written cosine of x times, change the tangent to sine of x over cosine of x equals sine of x. Okay? You write this cosine over 1 and you see that these 2 cosines cancel. And now I have sine of x equals sine of x. So again, don't be afraid if maybe you're like working with a friend on homework. If you're all getting different answers, you could still be correct. As long as you are using the rules correctly, you are correct. Okay? So if we look at this next question, those are not currently squared. Okay, so I can't do Pythagorean. I could change the sine and cosine, or I could do some arithmetic. Okay, now if I have 2 binomials, I can FOIL. FOIL says you multiply the first. So what is secant times secant? Secant squared. And then secant times a positive one is just a positive secant. A negative 1 times a secant is a negative secant. And then a negative 1 times a positive 1 is a negative 1. Okay? This positive and negative secant cancel out. And now I have secant squared of x minus 1, which that is a Pythagorean. What does that Pythagorean equal? Tangent squared. Okay? Now, for those of you that might remember conjugate binomials, you would see that whenever you have 2 binomials with the exact same terms but opposite signs, so for example, like a minus b and then a plus b being multiplied, it is the first term squared minus the second term squared. If you don't remember that rule, FOILing will take you to the same answer, so don't stress it. But if you do remember that rule, it will skip you down here, the first term squared minus the second term squared. Okay? All right, as you look at this next question, you hopefully spot this Pythagorean right here. What does 1 minus sine squared give you? Cosine squared. So I have secant squared of x times cosine squared of x. And now if I change to sine and cosine, what does secant squared give me? 1 over cosine squared times cosine squared. You can say this is over 1. And it all reduces. What is cosine squared over cosine squared? It equals 1. All right. For this next question, I'm going to suggest the steps that we used on the first question that we did today. Being that I have fractions, I'm going to write them horizontally. So I'm going to say secant of x divided by cosine of x minus tangent of x divided by cotangent of x. Okay? So now I'm going to start changing things to sine and cosine. Secant becomes 1 over cosine of x divided by cosine of x, and I'm going to write that over 1 so I can see the fractions nice and clean, okay? Minus tangent is sine over cosine, and then divided by cotangent is cosine over sine. Be careful not to cancel these out. Remember that you can only cancel when you are in multiplication, okay? The next step I'm going to take is my division, which is my keep, change, flip. So I have 1 over cosine of x times 1 over cosine of x minus sine of x over cosine of x times sine of x over cosine of x. Okay? When I combine this, I have 1 over cosine squared minus sine squared over cosine squared. Now, here I'm going to give you two options. Option number 1, maybe you caught that you have a common denominator, and I could say 1 minus, let's make a line here so you don't confuse it with this question. 1 minus sine squared all over cosine squared of x. And then what does 1 minus sine squared give you? Cosine squared. And this question also cleans up to 1. Okay? Option number 2, for those of you who like to break the rules, this is a good way to break the rule. 1 over cosine squared is also secant squared. And sine squared over cosine squared is also tangent squared. And this is one of your Pythagorean rules. Secant squared minus tangent squared also equals 1. Okay? So again, these are ors. These are ors. You can do either or of these. Okay? The safer bet would probably be the left side. It does take an extra step. But either way, you get the answer of 1.